discussing about the power system architecture. Okay, so in this class we are starting a transmission line parameters. Okay, so in previous first 2 years we are discussing how you can generate the electrical energy. Okay, so generation of electrical energy. From which sources we have to generate the electrical energy. Okay, those are from renewable energy sources and non-renewable energy sources. Those all are discussed in first 2 years. Okay, so now in this unit you have to discussing about the transmission line parameters. Once you can generate the electrical energy and then you can transmit to the consumers. Okay, so in this transmission line parameters, how and which parameters you can transfer that electrical energy to the consumers. Okay, coming so to transfer the electrical energy means through the conductors. Okay, transmission lines are nothing but conductors. Okay, first of all you have to know the what is the conductor and which type of materials are suitable for the conductors. Okay, and, conductors advantages, limitations, okay, all are discussed in this class. Okay, first of all, the transmission system transmits bulk power over the long distances at high voltage by reducing transmission costs, losses at low current. Okay, so why you are needing the transmission system is, so by using the transmission system you can transmit the large amount of power. Okay, bulk amount of power for long distances and at a high voltages. Okay, because of this you can reduce the transmission losses at low current. So you have to transmit that electrical power by using the conductors. Okay, what is the first of all, what is the conductor? See, a conductor is a type of material that allows the electrical current in one or more directions. Okay, so the conductor is a one material that allows, okay, that allows the electrical current in one direction or more directions. Okay, the conductors are used in the transmission lines are called overhead line conductors. So transmission means you have to transmit through the transmission lines and transformers is in the overhead. Okay, so that's why the conductors, the conductors which are used in the transmission lines are called as overhead line conductors. Okay, see, the overhead line conductors carries electrical power from sending of the transmission line to the receiving end of the transmission line. If you take a one transmission line, that is the sending end, receiving end. So okay, so here the overhead line conductors carries the current from sending end to the receiving end of the transmission line. Okay, so later you have to see materials used for overhead transmission line conductors. Okay, so which material? Okay, now you can see which materials are most suitable for the conductors. Okay, see, aluminum conductors. So mostly 90% we are using the aluminum conductors. See, aluminum conductors have an edge over copper conductors considering combined factors cost, conductivity, tensile length, weight, etc. Okay, whenever you have to take the aluminum conductors have an edge over copper conductor. Okay, at the edges you have to coating with copper for aluminum conductors. Those are used for the conductor for the transmission line. Okay, why? Because so these having the cost point of view, conductivity point of view, as well as tensile strength, weight, etc. When you have to take these all parameters into consideration, so at that time the aluminum material is more suitable. Okay, so that's why here you have to take in the aluminum for the overhead transmission line conductor. Okay, see here aluminum conductors has completely replaced copper conductor. Okay, in overhead power lines because of their low cost and low weight. Okay, so in the place of copper, okay, in the place of copper you are here you have to the aluminum conductors. Okay, why? Because the aluminum conductors have copper conductors. Okay, why? Because means okay, in overhead power lines because of their lower cost. Okay, so and lower. Okay, following 5 types of aluminum conductors materials used for the overhead transmission and distribution to carry generated power from the generating stations to the end users. So here you have to take 5 types of conductors. In aluminum conductors also there are different. Okay, so in that one here we have to use mainly 5 types of aluminum conductors, okay, to transmit the power from the generator station to the consumer. That is nothing but users. So those are AAC, AAC, AACSR, ACSR, ACAR. First of all, AAC is nothing but all total conductor is manufacturing with the only aluminum. Next one is what? All aluminum alloy conductor. Okay, so here alloy is nothing but aluminum is combined with the other material. The alloy, those are nothing but all aluminum alloy conductor. Okay, next third one is AACSR, all aluminum alloy. Okay, so conductor steel reinforced. Okay, aluminum alloy conductor reinforcing with steel material. Okay. So next one, aluminum conductor steel reinforced. Only aluminum. So there is only aluminum conductor steel reinforced. Those are nothing but. Next last one, aluminum conductor alloy reinforced. ACAR. What is the one types of aluminum conductors? AAC. That's what conductor. See, this type is sometimes is also referred as ASC. ASC is nothing but and conductor. Okay, so this is called as ASC. ASC is nothing but aluminum strand conductor. It is made up of strands of electrical conductor. Okay. So, it is made with the strands of conductor grade aluminum. Okay, AAC conductor has conductivity, having the conductivity of 1%. Okay. Okay. So, this AAC has because of its AAC has limited use in transmission and rural distribution. Okay, so it is used for the transmission purpose as well as the rural distribution. So next one, second one, all aluminum alloy conductor. Okay, so AAC. See, these conductors are made of aluminum alloy. It is a high aluminum, magnesium, silicon alloy. Okay, so that means it is the combination of aluminum, magnesium, and silicon alloy. Okay. This conductor offers good electrical conductivity about 50%. Okay, this provides the conductivity 52% with better mechanical strength. Okay, so also AAC conductor can be in coastal areas. Okay, so these are mostly in this type of transmission is used in the coastal areas. Why? Because they have an excellent corrosion resistance. Due to because of this property, we are using of conductors in the coastal area. So next is what? All aluminum alloy conductors. See, here is a combination of aluminum strands are helically wrapped around aluminum alloy. The combination increases the mechanical strength of the conductor. Okay, so that means whenever you have to reinforce with the steel, at that time it increases the strength of the mechanical strength of the conductor. So next one is aluminum conductor. See, ACSR. ACSR consisting of a solid or stranded steel core with one or more layers of higher purity of aluminum. Okay, so that means you have to take the one spiral. So in one spiral you have to wound the 1350 wires. Okay, 1350 wires will be wrapped in a one spiral. So the central steel core provides additional mechanical strength and hence sag is significantly less than all sag. Sag is nothing but the tensile property of the conductor is nothing but the sag. Okay, so significantly less than all other aluminum conductors. Okay, So ACSR with higher steel content is selected where higher mechanical strength is required, such as river crossings. Okay, so the ACSR conductors are mainly used in the where you need the higher mechanical strength. Okay, mostly in the river crossings. Okay, in those areas we are using the ACSR for the conductor purpose. Okay, ACSR conductors are widely used for the transmission and distribution purpose. Okay, these ACSR conductors are mainly used for the transmission purpose and distribution purpose. See, these are the ACSR conductors. See, inside steel reinforced and these are surrounding the aluminum conductors. Okay, see, aluminum conductors, steel reinforcing. Okay, so it's like a spiral. Okay, so this is nothing but the ACSR. Last one is what? ACAR. ACAR involves the combination of aluminum strands and helically wrapped around the aluminum alloy wires. Okay, surrounding the aluminum conductor, you have to wrap it with aluminum alloy wires. Okay, why? Because this combination will be increases the mechanical strength of the conductor. Okay, so these are the types of aluminum conductors. Okay, next, according to shape. Okay, according to shape. Okay, and physical properties. Okay, now you have to discussing the type of conductors. Okay, see, here the conductors are the following types. So in this one, first one is what? Solid conductor. Okay, so solid conductor. See, solid conductor consists of single piece of metal wire. Okay, so solid conductors are nothing but it consisting of a single piece. Okay, single piece of metal wire. It is cheap for manufacturing. Okay, so the solid conductors are in cost point of view for manufacturing. Okay, so the solid conductors are very cheap. Okay, skin effect is higher in solid conductors as at higher frequencies. Current flow on the surface of the conductors results in increases the effective resistance. Okay, but here in solid conductors, the skin effect is high. Why? Because, so see, in solid conductors at higher frequencies, current flows on the surface of the conductor results in effective resistance. Okay, so the main disadvantage of this solid wire is more rigid property. Okay, so and it having the more rigid. Okay, so this is the main disadvantage. Okay, so it cannot be bent easily. Okay, so the bending of the solid conductors is also not easily. Examples are iron, copper, aluminum, silver, etc. Okay, these are the examples for the solid conductors. So next one is what? Stranded conductors. Okay, see, standard conductors consisting of subconductors touch each other. Okay, so in standard conductors consisting of subconductors. Okay, so here is a single, in solid conductors you have the single piece, but in standard conductors you have the subconductors. It is costly to manufacture as compared to the solid wire. Okay, and in cost point of view also, it is costlier. Okay, the standard conductors are costlier to manufacturing compared to the solid wiring. Okay, for the given current carrying capacity, the size of the standard conductor is large compared to the solid wire. So whenever you have to take, okay, in capacity point of view, the standard conductor is large. Okay, so for current carrying capacity, the standard conductor is large whenever you have to compare with the solid wire. Okay, so different elements of standard can be put together. Okay, to get the transmission line of desired property. Okay, so in standard conductors, you have to wound. Okay, different elements of strands. Okay, different elements. See, if suppose you have to first wound with one, suppose aluminum, next copper, like this. Different. Okay, different elements of strands can be wound together to get the transmission line of desired property. Okay, proximity and skin effect is reduced using the standard conductors. Okay, to reduce the proximity and skin effect by using the standard conductors. Okay, examples. Okay, coming to the examples, the following are the examples of standard conductors. What are those? AAC, all aluminum conductor. AAC, that is nothing but all aluminum alloy conductors. That means all aluminum types of aluminum conductors are coming under the examples of the standard conductor. Okay, so see, AACSR, all aluminum alloy conductors, steel reinforced. Next one is what? aluminum conductor steel reinforced ACSR. Next one is aluminum conductor alloy reinforced ACAR. See, aluminum conductor steel reinforced cable, that is nothing but ACSR is a type of high capacity, high strength stranded conductor typically used in overhead power lines. Okay, whenever you have to compare these 5 types of aluminum conductors, here ACSR is nothing but aluminum conductor steel reinforced cable is a type of high capacity. Okay, so it is a type of high capacity and high strength standard conductor, and it is typically used in the overhead power line. Okay. Next one, so first we have to see the solid conductors. Next we have to see the stranded conductors. Next one is what? Composite conductors. Okay, so now we have to discussing about the composite conductors. See here, composite conductors are the composition of different metal conductors placed in a single strand. Okay, whenever you have to take a single strand, okay, in that strand you have to combine, okay, you have to different metal conductors in a place. Okay, that means in a single strand, that type of conductors, the name itself indicates composition. Okay, composition of different metals. Okay, so that is nothing but the composite conductors. Okay, see here, the composing conductors are made of various metals similar to the conductors. Okay, so here the composite conductors are made with various metals. Okay, similar to the conductors. These various metals conductors are placed in a single strand. This multiple composition of conductor in a single strand is termed as composite conductor. In composite conductors, the current divides equally for each conductors and flow efficiently. So in a composite conductor is nothing but you have two different elements. Okay, so in those all elements, the current flows will be equal. Okay, so the current will divide equally for each conductor and will flow efficiently. Okay, so for example, ACSR. ACSR is nothing but aluminum core steel reinforced. It is a composite conductor in which aluminum and steel conductors are mixed and formed as layers. Okay, so in ACSR, in aluminum core steel reinforced is a composite conductor in which aluminum as well as steel conductors are both are mixed and formed as a layer. Okay, so in figure, okay, so this is the diagram for the composite conductor. You have to observe in the composite conductor. See here, you have to steel. Okay, on the surrounding you have to place the aluminum. That is here the composition of steel metal as well as the aluminum metal. Okay, so those are nothing but the composite conductors. See, the outer strands are high purity aluminum. See in diagram you have to see outer strand. Outer strand is having high purity aluminum chosen for its good conductivity. Okay, so it's a good conductivity as well as low weight and low cost. Okay, conductivity is also good, weight is also low and cost is also low. Okay, the central strand is steel for addition mechanical strength to help the support of the weight of the conductor. Okay, the central is steel. Okay, the central strand is steel. Why you are using the steel is nothing but for additional mechanical strength to help support the weight of the conductor. Okay, for the additional mechanical strength to the conductor, okay, composite conductor and support, and for giving the support to the weight of the conductor, here we are using the composite conductor. See, you have to see limitations and advantages of the composite conductors. See, the composite conductors have following advantages. First one is coming to the advantages. The composite conductors allow high conductivity. Okay, so the composite conductors will allow the high conductivity. So next one, the mechanical strength of composite conductor is more than solid conductor. Whenever you have to take in point of view mechanical strength, so the mechanical strength of the composite conductors. Okay, here the mechanical strength of the composite conductors is more than the solid conductors. Okay, therefore sags are reduced and can be used for the long distances. Okay, whenever you have to mechanical strength is more, so at the time the sags will be reduced and used for the long distances. The corona law. So this what is corona and what is sag? Okay, these all are will be discussed in this unit later. Okay. The corona loss will be reduced with these conductors, and these are highly resistant for corrosion. Okay, whenever you have to using the composite conductors, the corona loss will be reduced. Okay, and these are very highly resistant for the corrosion. Okay, these are highly reliable. Okay, so the composite conductors are highly reliable. The proximity and skin effect are reduced with this conductor. Okay, so in this one, proximity and skin effect is also reduced. Okay, so limitation. Coming to the limitation, see, single stranded conductors, composite conductors used in transmission system usually up to 220 kV. Okay, so the single stranded conductors, that is nothing but composite conductors used in the transmission line up to for 220 kV transmission, but it is not possible to use single composite conductor for the voltages above 220 kV system. Okay, up to 220 kV you have to use the composite conductor. Okay, so above 220 kV volts transmission system, it is not suitable for to use the composite conductors. Okay, so these are the limitations of the composite conductors. Okay, so what are the advantages of the composite conductors? Is having high conductivity, mechanical strength, okay, and will reduce corona losses and highly reliable, and proximity and skin effect will be also reduced. Okay, so these are the advantages and limitations of the composite conductors. Next, you have to see the halo conductor. Okay, so coming to the halo conductor, okay, the diameter of the halo conductor is large as compared to the solid conductors for same current capacity. For suppose whenever you have to take 100 amperes, for that 100 amperes, if you have to take the halo conductors and solid conductors, so at that time the diameter, okay, so the diameter of the halo conductor is large whenever you have to compare with the solid conductors. Okay, whenever you have to compare with solid conductors, the diameter of the halo conductor is large for same current capacity. So, and what are the advantages of the halo conductors are? The corona loss is eliminated. In this one, the corona loss, okay, the corona loss will be also eliminated due to large diameter of the conductor. Okay, the skin effect of the halo conductor is also less as compared to the standard conductor. The inductance as well as inductance of the halo conductor is also less as compared to the solid conductor. As the diameter of the conductor increases, it exposes higher weight due to the wind pressure and ice accumulated on the conductor surface. Okay, so whenever the diameter of the conductor will be increases, so as the diameter of the conductor increases, it exposes. So at the time the weight will be exposed due to the pressure. Okay, due to pressure inside on the conductor surface. Okay, so the halo, the name itself indicates this will be a halo in shape. Okay, so the diameter of the halo conductor is large as when compared with the solid conductors for same current capacity. So coming to the advantages of the halo conductors, okay, so the corona loss is eliminated. The corona loss is eliminated due to large diameter of the conductor. Next one is what? The skin effect of the halo conductors is less as compared to the standard conductors. The inductance, okay, as well as the inductance of the halo conductor is also less compared to the solid conductors. Next one is what? As the diameter of the conductor increases, whenever diameter will be increases, it exposes to the higher weight due to wind pressure. Okay, so coming to the limitations. Okay, coming to the limitations of the halo conductors, the erection and maintenance of the halo conductors in EHV system, that is voltages above 220 kV, are not economical. Okay, so this is used for the maintenance. So erection and maintenance of halo conductors, extra high voltages. Okay, that means more than 220 kV, you have to use the halo conductors for transmission line purpose. But whenever we have to use the halo conductors, it is not economical. Okay, so this is the limitation of the halo conductors. Next one is what? Bundle conductors. And final next to last one in types of conductors, bundle conductors. Name itself indicates. Okay, so that means two or more subconductors per phase are placed at certain equal distance are called as bundle conductors. Okay, so that means we have to take two or more subconductors per phase are placed at certain equal distances are called the bundle conductors. They are used for transmitting power for long distances. Okay, that means These are used for the EHV. Okay, these are used for EHV, extra high voltage transmission, that is above 220 kV. Okay, so bundle conductors are nothing but, okay, the name itself indicates whenever you have to take the 2 or more subconductors per phase are placed at certain equal distances are called as bundle conductors. Okay, and they are used for the transmitting power for long distances. Okay, so that means they are used for the extra high voltage transmission, that is above 220 kV. Coming to the advantages, bundle conductors per phase reduce the voltage gradient in the vicinity of the line. Whenever thus reduces the possibility of the corona discharge. Whenever you have to take the bundle conductor, so there are reduced the voltage per phase, voltage gradient per phase. Okay, so that's why so at that time it will be reduces the corona. Corona effect will be observed when the medium present between the phases charged up and start to ionize act as a conducting medium. Okay, see, whenever corona effect is nothing but whenever air medium will be present between the phases are okay, RYB phases, okay, charges up to start the ionize. Okay, so at the time the air will be ionizes the wire, so that is nothing but the corona. Okay, so next one is what? Transmission efficiency can be improved by reducing the corona effect with bundle conductor. Whenever you have to reduce the corona, so at the time you have to increase the transmission efficiency. Okay, so here you can increase efficiency by reducing the corona. Okay, so next one is what? Bundle conductor lines will have higher capacitance to neutral in comparison with single lines. Okay, so whenever you have to take the bundle conductor is having the higher capacitance with neutral connection. Okay, whenever you have to take the neutral, so at that time the bundle conductor lines having the higher capacitance with neutral in comparison with single lines. Okay, single lines, they will have a higher charging current which helps in improving power factor. So whenever this having higher capacitance with neutral, so at that time the charging current will be increases. This will be improving in the power factor. Okay, so next one is what? Here I am says that bundle conductors having higher capacity and lower inductance. Okay, then the ordinary lines. Okay, so they will have higher surge impedance loading. So here compared to the ordinary lines, single lines, the bundle conductors having the high capacitance and lower inductance. Because of that, they exhibit the higher impedance loading. That is nothing but Z value. Z equal to L by square root of L by C. Higher surge impedance loading will have the higher maximum power transmit ability. Whenever surge impedance will be more, okay, whenever you can get the maximum surge impedance, at the time you having the maximum power transfer ability. Okay, see, with increasing self GMD and GMR, inductance per phase will be reduced compared to the single line conductor. So later the topics you have to discuss GMD and GMR. Okay, so GMD is nothing but geometric mean diameter and GMR means geometric mean radius. Okay, so there is two. Okay, so these two are the conductor parameters. Okay, so by the increase in GMD and GMR, that means diameter and radius, the inductance per phase, okay, the inductance in the per phase will be reduced compared to the single conductor line. Okay, so this results in the lesser reactance per phase compared to the ordinary single line. Okay, whenever inductance per phase will be decreased, so at the time this will be result to the reactance per phase will be also decreases compared to the single line. So that means the reactance losses, okay, the reactance losses will be less. Okay, similarly the interference with the communication lines, okay, interference with the communication lines is also reduced in the transmission line. Communication with interference with the communication lines in transmission lines is also reduced with the bundle conductor. Okay, so these are the advantages of the bundle conductors. Okay, so now in this class we have to discussing about the for transmission purpose we have to must and should need conductors. Okay, you have to use next you have to discuss the materials used for the conductors. So mainly we are using the aluminum and types of aluminum conductors. Next, we have to see the types of conductors. What are the types of conductors? Solid conductors, okay, composite conductors, halo conductors, and bundle conductors. Okay, so those all are discussed in this class. Next class, we have to discussing the transmission line parameters. Okay, those are resistance, transmission line inductance, resistance, capacitance. Those all are discussed in next class. Thank you.